Welcome to this explainer. Today, we're building a science-backed toolkit to totally transform how you learn, encode, and retain information. We're taking a comprehensive look at the actual science of studying, cutting right through the myths and building a strategy that actually works based on cognitive psychology and neuroscience. So let's just dive right into it.
We have all experienced this frustration, right? You spend hours cramming for a massive test, a certification, maybe a language exam. You feel completely prepared, only to sit down the very next day and just draw a total blank. The information was right there, but somehow it just vanished. Why exactly does our brain betray us like this?
Well, the culprit is what cognitive psychologists call the illusion of fluency. It's basically a psychological trap where recognizing information, like when you reread your highlighted notes for the third time, makes you falsely believe you've securely learned it. Your brain essentially confuses the ease of reading with the actual ability to retrieve.
To dismantle this illusion, we're going to follow the journey of a memory. Our agenda today covers 5 critical steps: the illusion of fluency, taking notes and understanding, active recall and blurting, interleaving versus blocking, and finally, hacking long-term memory. Starting right off with Section 1, the illusion of fluency, why easy practice fails. Let's look at why study methods that feel the most productive in the moment are often the absolute least effective for our brains in the long run.
Let's talk about a pretty staggering statistic: 78%. In a landmark study by researchers Cornell and Bjork, participants were asked to learn the styles of various painters. Some studied one artist's paintings in a solid block, while others had the artists mixed up or interleaved. A massive 78% of students believed studying one topic at a time worked better for them. But here's the kicker. They maintained this metacognitive illusion even after their own test scores directly proved that mixing the topics up resulted in much higher accuracy. Our brains actively lie to us about how well we're actually learning.
Okay, moving right along to Section 2, taking notes and understanding, encoding the right way. The journey of a memory really starts with your initial exposure to the material, and managing your brain's cognitive load is absolutely crucial here.
You know, there's always an endless debate about the perfect note-taking system. But honestly, the process matters way more than the system itself. Elaborate systems like the Zellkasten method are fantastic for researchers building interconnected knowledge over decades, but let's be real, they're total overkill for students studying for an exam. Simpler methods like the Cornell method win out because they intentionally build retrieval practice right into the note structure itself, using a cue column on the left to test yourself later.
And this is a big one. Research consistently shows that handwritten notes completely outperformed typed notes for conceptual learning. Why is that? Because handwriting is slower, which is exactly what we want. It forces you to mentally process the information, pick out the most important points, and paraphrase them into your own words. When you type, you're often just mindlessly transcribing what you hear like a court stenographer, which totally bypasses the deep cognitive processing you need for true learning.
Next up, Section 3, active recall and blurting, practice that works. So you've properly encoded the material. Now it's time to practice actually pulling that information out of your brain.
Now, if you doubt the power of testing yourself, consider the number 49. A massive systematic review by cognitive scientist Pooja Agrawal looked at applied classroom research and found an overwhelming 49 positive effect sizes, proving that retrieval practice, the act of actively recalling info without looking at your notes, consistently and significantly boosts student learning compared to passive review. A surprisingly simple and highly effective way to do this is called the blurting method. The cycle goes exactly like this. You briefly review a topic. Then, you completely hide your notes. You grab a blank piece of paper and write down or just blurt out absolutely everything you can remember. After that, grab a different colored pen, check your notes, and fill in the gaps. Review, hide, blurt, check, repeat. This rhythmic cycle literally forces your brain to reconstruct the information, which strengthens those neural pathways every single time you do it. Another incredibly powerful active recall tool is the Feynman technique, inspired by the Nobel Prize-winning physicist. As the famous quote often attributed to Einstein goes, "If you can't explain it simply, you don't understand it well enough." The Feynman technique pushes you to explain a topic entirely in your own words, ideally as if you were teaching it to a 5-year-old.
Let's break down how this builds into a structured process. First, orient and set your goal by identifying a specific concept. Second, practice recall by writing out an explanation using incredibly plain, simple language. Third, build metacognition. The moment you find yourself getting stuck or having to fall back on complex jargon, you've instantly pinpointed your weak spots. Finally, simplify it even further by using everyday analogies. It's a slightly brutal but highly effective mirror for your actual level of understanding.
All right, Section 4, Interleaving versus Blocking. Desirable difficulties. Let's explore how making things feel harder actually supercharges your retention.
Blocked practice is how almost every textbook is written. You practice skill A repeatedly, then skill B, then skill C. It feels smooth, right? It feels easy. Interleaving, on the other hand, shuffles related skills all together. You might do a problem from category A, then C, then B. It feels clunky and confusing. But here is why it works. Interleaving forces your brain to do the hard work of identifying the problem type first before applying the solution strategy.
The proof is literally right here in the data. In a major experiment with 7th graders in Tampa, researchers tested this exact concept with math problems. When tested after a 30-day delay, the group that used interleaved practice retained a massive 74% of the material, and the group that used standard block practice, their scores totally collapsed to a dismal 42%. By creating that desirable difficulty during practice, the interleaved group nearly doubled their long-term retention.
And get this, we can actually see this happening inside the brain. Brain scans taken during these learning exercises show that interleaving heavily recruits the prefrontal cortex. That's the area involved in planning and executive control. The brain is sweating, working way harder during the learning phase. But incredibly, when tested days later, the interleaved brain shows a neural efficiency signature. Because it worked harder initially, it requires so much less effort to successfully recall the info later on.
Bringing us to our final step in the memory journey, Section 5. Hacking long-term memory, spacing, and palaces. Now we need to ensure this information sticks for the long haul.
Spaced repetition is pretty much the ultimate hack against forgetting. It exploits the spacing effect, which was first documented way back in 1885 by Hermann Ebbinghaus. Instead of cramming, you schedule your reviews right at the edge of forgetting at increasing intervals, say 1 day, 3 days, 1 week, and then 1 month. You are essentially telling your brain, hey, don't delete this, I still need it.
Lots of people use smart apps like Laxu AI or Anki, which use algorithms to calculate these optimal intervals automatically. But whether you use high-tech AI or physical flashcards, the science shows that consistency is the absolute key here. Research from 2009 proves that brief, consistent daily review sessions will always trump long, spaced-out cram sessions. Just a little bit every day really does do the heavy lifting.
But hey, what if you have to memorize a massive volume of highly complex stuff, like medical terminology? Enter the memory palace. This technique was famously invented by the Greek poet Simonides of Chios. After narrowly escaping a tragic roof collapse at a banquet, he realized he could identify the victims simply by mentally walking back through the room and visualizing exactly where everyone had been sitting. You can totally use this exact same spatial wiring to your advantage. First, pick a familiar location, like your house. Second, plan a strict mental route through it. Third, and this is where it gets fun, assign the abstract facts you need to learn to specific spots along the route by creating vivid, bizarre, highly exaggerated mental images. Like, if you need to remember an anatomy term, picture a giant, exaggerated heart interacting with your kitchen sink. By translating abstract facts into spatial and visual data, you completely bypass your brain's normal limits.
So we've gone from the pitfalls of easy reading all the way to building mental palaces. We've seen that the illusion of fluency is the real enemy, and that making your practice feel just a little bit harder, whether through active recall, interleaving your subjects, or spacing out your sessions, actually makes the resulting memory exponentially stronger. I want to leave you with this question. Which of these science-backed, desirable difficulties are you going to embrace in your very next study session? Thanks for joining me on this explainer, and happy studying.